into yelling at my child. Work comes 7th hour. There's no child to yell at them. I really, really, really want to get through this today, secant and cosecant, because if we get through this today, then we'll be caught up to 2nd hour. And so the idea is once we do tangent and cotangent and we realize they're asymptotes, hopefully maybe it makes sense to you that secant and cosecant are also going to have asymptotes, because how could we rewrite secant? We could write that as 1 over cosine, and you can't have 0 in your denominator. So just like tangent has cosine at the bottom, it's going to have the same asymptotes that tangent had, because tangent and secant both have cosine in the bottom. So we could say that we know our asymptotes are going to be wherever cosine of x equals 0. And this is a part that you have to know. You have to know cosine is the x-coordinate. So where does cosine equal 0? Oh, that's going to be on the y-axis. So that's going to be at places like pi halves and 3 pi halves and so on, just like tangent. And so we can say that the asymptotes are always going to be at pi halves plus pi n, just like tangent. So if I make a graph here, and I do like negative pi halves, pi, 3 pi halves, negative pi, negative 3 pi halves. Again, start with your asymptotes, and then we want to think about what the graph of this is going to look like. So I know my asymptotes are going to be everywhere that cosine equals 0, and cosine equals 0 at pi halves, at 3 pi halves, at negative pi halves, and at negative 3 pi halves. And again, on this first one, I'm going to pick a few points. Just like tangent and cotangent, the idea is once you know the shape of it, it's pretty easy to do, especially if you know what cosine looks like. So again, just like tangent and cotangent, pick halfway in between your asymptotes. So if I pick halfway in between these, do you agree I'm going to be at 0? So that's my first point. I can get my pen out of my pocket. Secant of 0 is the same as 1 over the cosine of 0. What is the cosine of 0? 1. X is 1 at 0. 1 over 1 is 1. Cosine starts up at 1, so guess what? Secant also starts up at 1. But it's the reciprocal of cosine, so it's not going to look the same as cosine. I'm going to pick one more point just to show you what happens here. If I picked halfway in between, it's not as pretty as tangent, because the tangent of pi force is great. It's just 1. The secant of pi force is going to be 1 over the cosine of pi force. What's the cosine of pi force? It's 2 square root 2 over 2? So it's just the square root of 2, which happens to be about 1.41. Which means instead of going down like cosine, it's going to actually go up. And remember that cosine and secant are even functions, or if you do the negative angle, if you do negative pi force, down in quadrant 4, cosine is still positive. So you get the same answer. And we could keep going, but the closer that we get to pi halves, the bigger that secant's going to keep getting. And again, that's where the asymptotes, I think, are helpful, in that it's just going to kind of look like a parabola in between those asymptotes. And what's going to happen if I go over here to pi? also go up to 1. What's the cosine of pi? It's negative 1, because over here I'm at negative 1, 0. X, kids, we gotta know this. So that means I'm down here at negative 1. So instead of being a parabola going up, guess what's going to happen? It's going to go down, because halfway in between is going to be negative 1.41-ish. And it's going to look like this. I'm going to graph cosine on here just because I want you to see what's happening. You don't need to do this on yours unless you just really want to. But if you graph cosine, cosine looks like that. So you see how we're kind of taking in between where those asymptotes are, and we're just kind of flipping that over? That's because it's the reciprocal of cosine. So everywhere that cosine has like a hump up, it's going to have a parabola going that way. And every time it goes down and dips down, it's going to flip over and go down. So some people like to think about it in terms of what does cosine look like, and then I'll just flip those over. But for me, I just pick those high and low points. So going over here, I know at negative pi, it's also going to be here at negative 1. And then it's going to go down from there. And then it's just going to keep repeating itself. It's going to go parabola down, parabola up, parabola down, parabola up, parabola down, and it's just going to keep repeating itself just like cosine. Important thing that I want to say about this is that the period is back to 2 pi over b. The only reason that tangent and cotangent only have a period of pi over b is because between every asymptote is exactly the same. But for secant, it takes 2 sets of asymptotes for it to start repeating itself. Like, it's not going to start going back up until I get over here again. So it is 2 pi over b. Notice that cosine is stuck between negative 1 and 1, and secant is the exact opposite of that. Like, it's everywhere but negative 1 and 1. And that's what secant looks like. Find your asymptotes, and every time you just go up. What do you think is going to happen if there's a 3 in front of that? Yeah, so instead of starting at 1, think about the amplitude of cosine. That parabola is going to start up at 3, and then it's going to go up. But yeah, the only points I ever graph on my secant and cosecant graphs are that start of the parabola, and then I just wing it from there with my asymptotes. Sam?
I went up 1. Is that just for 1 and the secant is under 0?
Yes. Also because when you plug in 0 there, you get 1. But yes, it's just like because there's a 1 in front of that. That's a good way to think about it. It's like the amplitude of cosine. And a negative is going to do the exact same thing that a negative did. So if there was a negative in front of it, that first one's going to go down, and then it's going to be the opposite.
So like, what's that? 1 will go to negative.
Yes, because if it was negative secant, then this would start at negative 1, and then that one would go up, because negative flips it over. Those same transformation things. The same thing's going to work for cosecant. The only difference is the asymptotes are different, just like with cotangent. And again, the shortcuts are great. When I graph secant, cosecant, tangent, cotangent, I never make an XY chart, and that's what I'm trying to get you to the point of, that you don't have to make an XY chart every time. And so just remember that this is sine on the bottom, so its asymptotes are going to be the same as cotangent, or sine's on the bottom, are going to be, where sine of x equals 0, which is like 0 and pi and 2 pi, or we can say at pi times n. So the good news is, even though we have 4 graphs, like they're paired up with their asymptotes. Tangent and secant have the same asymptotes. Cotangent and cosecant have the same asymptotes as the original graph. And so if I was going to graph this one at like pi, I'm going to squish this in here and make this 2 pi, negative pi, negative 2 pi. Again, it's going to go right with the way sine goes. It's going to be wherever sine goes up, it's going to have a parabola that flips up. And whenever sine kind of goes down to the bottom, it's going to flip down the other way. The asymptotes are where sine equals 0. And sine equals 0 at 0, just like tangent and cotangent, when they ask you to match the graph with the equation, the asymptote should be what you're looking at, because cosecant is always going to have an asymptote on the y-axis, because sine starts at 0. So 1 over 0 is undefined. And then from there, again, I'm going to draw sine in here just so you can kind of see what I'm talking about here. This is what sine looks like. Remember, it goes up like this and then down like this. So cosecant is going to start at that high point on sine, and then it's just going to be kind of flipped over. And it's going to go up like that. And then whenever sine is -1, cosecant's also -1, and it flips down like that. That black graph that I drew, you don't have to draw. That's not really part of cosecant. I just wanted you to see how it's connected to sine.
So if we get the first point down, just
Yeah, if you get the first point, you should know every point after that, right? If you get your asymptotes right, you should know every point after that. The asymptotes, I feel like, are the key point in doing these. And then again, it's just going to keep repeating itself. Up, down, up, down, up, down, up, down. The period is going to be 2 pi over b. So let's write out our rules for asymptotes, and then let's see maybe if we can graph one with the transformation. But I feel like after we've done all of these, the numbers in front do the same thing, the negatives do the same thing. The period changes your asymptote. If you've been staying up on your homework, throwing in a different graph, the same rules apply when we throw those numbers in. But the asymptotes are most important, so I might be like going out of order here. Oh yeah. 2 consecutive asymptotes. That's what you got to know how to do. And so we're just going to write this out, and I cannot stress enough. In second hour today, they had this homework yesterday, and the big question today for people that had trouble with it, I don't know how to find my asymptotes. And I said, we wrote it out yesterday. If you get stuck on your homework tonight and you say, I don't know how to find my asymptotes, this is what you're looking at. If you have tangent of something, I don't know why I wrote tangent all the way out, but that's all right. Tangent and secant are going to have the same asymptotes because they both have cosine in the bottom. And every time to find 2 consecutive asymptotes, you're going to set whatever's here, bx minus c, you're going to set it equal to negative pi halves, and you're going to set it equal to pi halves, and you're going to solve it. When we graph these, you're never going to have a c value, and so it's always just going to be bx equals c if you're graphing it. But you got to know that. I always think about what's in the bottom. Like, honestly, like in my head, I was just thinking cosine's in the bottom, so how do I know what I set it equal to? It's where cosine equals 0. And then cotangent and cosecant, and if you're looking for a shortcut to remember those, you should be able to remember they go together because they're both the co-functions, not cosine because it doesn't have asymptotes, but cotangent and cosecant both have sine on the bottom. And so to find their asymptotes, you're going to set that equal to 0 and that equal to pi. Sam?
both have asymptote of 0.
Yes. And so it wasn't Aaron today said he always remembers that because they both have an O in them, and O, it looks like 0, so he always remembers 0 as an asymptote, and I was a little lost by that, but you know, whatever works. Right? So this is kind of your go-to thing today. So we're not even graphing these. I just said find 2 consecutive asymptotes. I will tell you on your test for this chapter, there are questions like this where you don't have to graph it, but I want to know that you know how to find asymptotes. And the directions say find 2 consecutive asymptotes for the given functions. And I threw one in here with a c value just so you could do the algebra. You would never have to graph something like number 3, but you could graph something like number 4. And you just got to know, without your notes on the test day, you got to know secant is 1 over cosine, and cosine is 0 at negative pi halves and pi halves, which means you're going to set this 4x minus pi equals negative pi halves, and 4x minus pi equal to pi halves. And then you just do the algebra. People always make pi mistakes. Pi is really a number, but when you're dealing with it in an equation, you kind of treat it like a variable. You can only add pi to other pi's, and so don't add something to pi that doesn't have pi in it. But if I added pi to both sides here, right, it's like negative 1/2 pi plus 1 pi would leave me with 1/2 a pi. I always tell people, some people get really confused by this, and I always say, you can do that on your calculator, just leave the pi out of it and then put pi back in. Like you could take negative 1/2 plus 1 and put pi in it. You're dividing by 4 here, and for some reason we really, really struggle with dividing fractions into fractions. But remember that dividing by 4 is the same as multiplying by 1/4. And so the answer there is really pi over 8. When there's a C value, don't just automatically say, oh, the next one's negative pi over 8, right? It's going to change because we're adding different now. If I add pi to positive pi halves, that's like 1.5 pi, or 3 pi halves. So when I divide by 4, that's the same as multiplying by 1/4. I get 3 pi over 8. And sometimes I think the hardest part that people struggle with is, okay, I got 2, and now when I'm graphing it, how do I get the next one? They have to be equal distance, so you can always like figure out the distance between that and then add that amount to your next asymptote. It would. So if you want to use 3 pi over 2 and pi halves, that will work. As long as you go in order. Like if you're going to use 3 pi halves, then set it equal to pi halves and 3 pi halves. You see what I'm saying? Like you have to go 2 in a row. So I always pick one negative and one positive, but you're right. This is also going to be next asymptote. You would set it equal to 3 pi halves and solve it again. You see what I'm saying? So that works. As long as you have 2 in a row, I don't care which 2 you start with. I just always start with these. This one's much easier because there's no C value. But for cosecant is sign on the bottom. So we would say like 3x equals 0 and 3x equals pi. And the same idea on that one, Sam. This is also undefined at 2 pi and at 3 pi and at 4 pi. You can pick any of those. I just try to give you like a standard one you can always go to. But as long as you pick 2 in a row to start with and you solve it, you'll always get the right answer. If you want to make my life harder as a grader, pick 2 in a row that aren't the 2 I pick, and then I have to work it out still. So. And I like cosecant and cotangent because they always have one at 0 for the ones we're going to be graphing. And then that one would be pi thirds. Asymptotes, super important. How do you feel about this? There's also more of the solving equations. So we have about 5 minutes left. So you tell me, we'll decide what we want to do. Do you want to do another, like an actual one that we graph, where the asymptotes are different? Or would you rather do one where you have to solve, like, for the angle, like secant of what equals square root of 2, right? Like the end of the homework from yesterday. Do you have any clue what I'm talking about right now? Like this kind of question? Would you rather do that, or would you rather look at a graph? This is what we did for day 1. This is what we did yesterday. Like if you notice, all the questions on your homework yesterday, I only picked tangent and cotangent problems, because that's what we talked about. Tonight, you're going to have pretty much the same exact homework that you had last night, only it's with secant and cosecant. And again, you can do these with a calculator or without a calculator, depending on the problem, and your homework breaks them up. This one is definitely with a calculator, because 1.2 is not something I can get from my unit circle. So you've got to know how to do this on a calculator. But remember that your calculator is only going to give you one answer if you're looking for 2 answers. If secant equals 1.2, what does that mean cosine equals? 1 over 1.2, right? And then on my calculator, I'm going to use that inverse cosine button. And make sure sure you pay attention to this part. Sometimes they just want you to give an answer in quadrant 2, or just quadrant 3, or just quadrant 4. And whatever quadrant they give you, that's where your answer has to be, even if your calculator gives you a different answer. But when they ask you to go all the way around the circle, you've got to remember that your calculator is only going to give you one answer, and you have to use reference angles to get the other ones. So in radian mode, I'm going to do inverse cosine of 1 divided by 1.2, and I'm going to get that that is true at about 0.59 radians. And that's part of my answer. But what I'm really trying to get across here, 4-4 day 1, what we did yesterday, again today, is that if you're going around that entire circle, cosine and secant will always be positive 2 times. It's going to be positive once in quadrant 1, which is where that 0.59 comes from. What other quadrant is cosine and secant positive in? Four, right? Cosine is x, right? Where is x positive? X is, yes, you were doing, yesterday we did tangent and cotangent, which are my favorite ones to do, because you always just add pi or subtract pi, and it's super great. But cosine and sine and secant and cosecant are a little bit trickier, because cosine is positive here and here. This is where, even if you love the unit circle, you have to know about reference angles to do these problems. You have to say, don't leave if the bell rings. You have to know that if this is 0.59, the distance from here to here is also 0.59. That's a reference angle. My question is, how am I going to go from 0 all the way around to that line? What math could I do there? Would that give me what's left? Yes, and every time I do one of these problems, I draw a picture and I think about where am I? What could I do? Sometimes you're going to have to subtract from 2 pi. Sometimes you might have to subtract from pi. Sometimes you might have to take pi plus the angle. Draw the picture, and I'm sure we'll talk about some of these tomorrow because they're a little bit tricky sometimes. But just know, draw the picture and see if you can figure out that reference angle. And I'm just going to take 2 pi minus 0.59, and the other answer would be 5.69. Okay, so try these tonight. We're going to go over questions tomorrow. Tomorrow's a worksheet day, which means you know what that could also mean. So, you know, do your homework. Hint, 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 hint.
You'd like the English secrets scenario to feel.
And if you notice, these are right next to the problems you did yesterday. Yesterday you did 2 and 4, so guess what today you're doing? 1 and 3. Same kind of idea where there's a blue graph and a red graph. And then I think there's like 4 in the middle here that you're graphing, just like you graphed 5 and 6 and 13 and 14, now, or 10 or whatever. Now you're graphing 7, 8, 11, and 12, matching. These are all solving, okay? So try these. Come in the morning if you have a lot of questions. All of them.
Examples, please. I need to press with Patrick,
This is 4, 5, and 2.
Megan Rogers, Jonathan Holt, Caitlin Stanton,
Precalculus.
Clayton Bidito, Joe Waters, Jake Wiggs. Examples, please.
Hey, the sky's starting to get darker.
And then I thought it was going to be worse weather today, and then it hasn't been.
It's